नमस्ते विद्यार्थी भाइ बहिनीहरू। आजको क्लास मैले साइन्सको क्लास 10 को फर्स्ट च्याप्टरको एक्सर्साइजका क्वेसनहरू केही सल्भ गरिदिन गइरहेको छु। फर्स्टमा एक्सर्साइजको बी क्वेसन नम्बर 4 को हेरौँ। त्यसमा under what condition do the values of gravitational force and gravitational constant become same equal? हामीले चाहिँ ग्रेभिटेशनल फोर्स र ग्रेभिटेशनल कन्स्टेन्ट को भ्यालु कुन कन्डिसनमा इक्वल हुन्छ भन्ने कुरा चाहिँ डिराइभ गर्नु छ। त्यसको लागि लेट the two bodies each of mass 1 kg and the distance between them be 1 meter. Then by the law of gravitation we get the formula. We already have derived the relation, that is F is equal to capital G m1 m2 upon d square. Here mass of first body m1 is equal to 1 kg, mass of second body m2 is equal to 1 kg, and the distance between them is 1 meter. Then by applying the formula we get F is equal to G, here m1 is 1, m2 is 1, and distance between is 1 meter, that is 1 square. Then by solution we get Fg into 1 upon 1 or F is equal to G. In this condition, the condition is mass is 1 kg, first mass, second mass is 1 kg, distance between is 1 meter. Then by the relation derived from Newton's law of gravitation, we get F is equal to G. In this condition, force of gravitation becomes equal to the universal constant of gravitation. Conclusion, यसलाई हामीले कन्क्लुजनमा के लेख्न सक्छौं भन्दा therefore for two bodies each of mass 1 kg and distance between them be 1 meter, then the force of gravitation then the force of gravitation become force of gravitation becomes equal to the universal constant of gravitation, that is F is equal to G. यो क्वेश्चन सॉल्व भयो. क्वेश्चन नंबर 4 एक्सरसाइज को क्वेश्चन नंबर 4. अब क्वेश्चन नंबर 5 लाई हेरौं. क्वेश्चन नंबर 5. क्वेश्चन नंबर 5 में छ फिगर छ त्यहाँ. The Earth's orbit is oval in shape. At the center there is sun, and Earth revolves round the sun in the oval shaped orbit. Here this point is given as A, this point is B. This is Earth. This is Earth. And at the center there is sun. And the question is, Earth's orbit is oval in shape. Explain how the magnitude of the gravitational force between the Earth and the sun changes as the Earth moves from position A to position B. As the Earth moves from position A to position B, then what changes will occur in the value of force of gravitation? First of all, as we know that force of gravitation between any two bodies is inversely proportional to the square of the distance between their centers. This law is applicable in this condition. Here, the distance from sun to earth is more in position A than the distance from the sun to earth in position B. यहाँ के छ भने A पोइन्टमा हुँदाखेरिको डिस्टेन्स चाहिँ बढी छ, B पोइन्टमा हुँदाखेरिको डिस्टेन्स चाहिँ कम छ. As we know that the force of gravitation between two bodies is inversely proportional to the square of the distance between their centers. And the distance in position A is more than the distance in position B between sun and the earth. Here in changes earth moves from position A to position B as shown in the figure. Here in position A, the distance is more. In position A, distance is more than the distance in position B. Therefore, force of gravitation will be less. More the distance in position A, less will be the gravitational force, as it varies inversely to the square of the distance. Therefore, in position A, force of gravitation will be less than in the position B, due to the inverse relation of force of gravitation with the distance. Here we can write, here in position A, distance is more than the distance in position B. Therefore, in position A, force of gravitation is less. More the distance, force of gravitation is less. In position A, force of gravitation is less than the force of gravitation in position B. That means force of gravitation is less in position A, and force of gravitation in position B is more than in the position A. यो क्वेश्चन नंबर 5 हो. अब क्वेश्चन नंबर 6 लाई हेरौं. ओके, अब हामी क्वेश्चन नंबर 6 लाई हेरौं. क्वेश्चन नंबर 6 मा छ, द एक्सेलरेशन ड्यू टू ग्रेभिटी अफ द मून इज 1.67 मीटर पर सेकेंड स्क्वायर. व्हाट डज इट मीन? चन्द्रमामा गुरुत्व प्रवेगको मान 1.67 मीटर पर सेकेंड स्क्वायर हुन्छ भने यसको अर्थ के हुन्छ भनेर सोधिरहेको छ हैन. अब यसमा फर्स्टमा हामीले एक्सेलरेशन ड्यू टू ग्रेभिटी भनेको के हो भन्ने बुझ्नु पर्यो. मुनमा चाहिँ एक्सेलरेशन ड्यू टू ग्रेभिटी को भ्यालु g at moon is equal to 1.67 मीटर पर सेकेंड स्क्वायर हुन्छ भन्यो भने व्हाट डज इट मीन भन्यो. जस्तै यही भ्यालुलाई हामीले अर्थ सर्फेसमा चाहिँ नियर द अर्थ सर्फेस भ्यालु अफ g इज 9.8 मीटर पर सेकेंड स्क्वायर भन्छौं. लाइकवाइज भ्यालु अफ g इन मून नियर मून सर्फेस इज 1.67 मीटर पर सेकेंड स्क्वायर. अब यसको मिनिङ हेर्नलाई हामीले एक्सेलरेशन ड्यू टू ग्रेभिटी को मिनिङ बुझ्न पर्यो. अब एक्सेलरेशन ड्यू टू ग्रेभिटी इट मीन्स, ओके, यो क्वेश्चन नंबर 6 को मिनिङ लेख्नु भन्दा पहिले हामी एक्सेलरेशन ड्यू टू ग्रेभिटी भनेको के हो त्यो त्यसको डेफिनेसन लेखौं. द एक्सेलरेशन produced in a freely falling body due to the force of gravity of a planet or satellite पनि भन्ने हो. यहाँ मून को भ्यालु सोधेको हुनाले हामीले त्यो सेटेलाइटमा पनि जी को भ्यालु हुने भयो. ग्रेभिटी अफ अ प्लानेट or satellite is called acceleration due to gravity and the symbol of acceleration due to gravity is small g. By this definition, यो डेफिनेसन को अनुसार हामीलाई क्वेशनमा दिएको मून मा g को भ्यालु 1.67 मिटर पर सेकेन्ड स्क्वायर को मिनिङलाई यो अनुसार अब हामीले के भन्न सक्यौं त भन्दाखेरि इट मीन्स near the moon's surface the acceleration produced in a freely falling body near the moon's surface. अब यहाँ मून को जी को भ्यालु भएको हुनाले हामीले मून सर्फेसमा भन्नु पर्यो. नियर द मून सर्फेस इज produced in a freely falling body near the moon surface is 1.67 meter per second square. In other words, it means also for a freely falling body near moon surface, its velocity increases by 1.67 meter per second per unit time, that is per second. In other words, अब अर्को तरिकाले यसलाई लेख्दाखेरि मिनिङ लेख्दाखेरि in other words, near the moon surface for a freely falling body its velocity increases by 1.67 meter per second per unit time. That means per second. In each second, the velocity of the body increases by 1.67 meter per second near the moon surface. यसको मिनिङ त्यो हुन्छ.